For this demonstration, I went back to the project that we were using in the last module, the module on generic collections. You might remember that during that module, we were trying to model departments, where departments were something that had a name and an associated list of employees, and an employee object really just had a name property. That's the only property we were worried about. In a real application, your employee will probably have a birth date and an ID and all sorts of other information, but we're just concerned about employees by name. And what we are trying to do is model these departments using a dictionary of string and list of employee. The key is a string, the value is a list of employee. And we're creating departments like the engineering department and using the dictionary to map that to 0 or more employees. So I just want to add a few employees to engineering. Let's add an employee, Scott. And now I can copy that line of code to make this go a little bit faster. We'll add a few more employees inside of here. And then we can create another department too. So let's create a sales department. And I just need to take that string and place it here. We'll just have 2 employees in the sales department. We'll call them Joy and Danny. And now one of the things that the application wanted to do was print out a report of all the departments and all the employees that are inside. So I want to go through each item that's in that department's collection and right line out the item.key. The key will be engineering or sales. And then I want to loop through all the employees that are associated with that key value. So for each employee in item.value, I want to write line after a tab character to sort of space it over the employee's name. And I'm just going to do one quick fix. I don't want to call this item. I want to name it properly. We'll call it department. That makes the code a little more readable. And now run this. And we get out engineering and sales, and it looks like all the employees are in there correctly. And you might remember in the last module, we'd actually placed sales into the collection first. And now if I run this, the output comes out as sales and then engineering, but the business always wants to see this in sorted order. And we did that in the last module. It was very easy. We could have used an order by operator, but instead, we switched over to a sorted dictionary, and we also tried out the sorted list. For this, I'll use the sorted dictionary. And now I run this again, and the output comes out as engineering and then sales, because a sorted dictionary sorts by the key value, and since the key value is a string, most things in the .NET framework, they know how to sort strings. And the default sort order is ascending, alphabetical, case sensitive, and culture sensitive. So that was an easy problem to solve. But another problem that we ran into in the last module is that we also wanted to make sure that we didn't duplicate any employees in any department. So if someone adds Danny twice to the sales department, we don't want to see Danny twice in the output. And unfortunately, we do. And of course, this is trying to maintain a department of employees that are unique by their name, which is almost impossible. You can imagine that might be an ID property or some other form of unique identifier. It doesn't matter what the property is that we want to use to uniquely identify an employee. We're going to have problems trying to uniquely identify an employee unless we write some code. Because we could make this a hash set of employee. And we saw in the module that a hash set only allows unique items inside. But once I fix this code and we run the program once more, what we'll see is the hash set doesn't know how to identify employees. It doesn't know how to compare them. It doesn't know what makes them unique. It's just going by object references by default. So we try to add 2 employees named Danny, and now we have a Danny in engineering and a Danny in sales. There's Dannys everywhere, but we need to make sure there can only be 1 Danny per department. So we have part of the problem solved by using a hash set, but the hash set's going to need some more information to figure out what uniquely identifies an employee. Well, it turns out we can use one of the interfaces that we just talked about in the last clip, because one of the overloaded constructor versions for the hash set allows me to pass in an object that implements I equality compare of employee. And the hash set will use that objects to compare the incoming employee objects to see if they're equal. So let me create a class that implements that interface. I will call this class the employee comparer. It implements iEquality compare of what? And what we did before was we would take a generic type parameter t on our class and we would forward that down to the interface definition. But that's actually not what we want to do here. We know exactly the type that we want to compare when we write this class. We know that this class is dedicated to employees. When I use a generic type parameter here, what I'm trying to do is defer the definition of that type to runtime, to let the client decide what they want to use. Here, I know at compile time what I want to do is compare employees. So instead of trying to use a generic type parameter with iEquality compare, I'm going to give it a type argument. I'm going to say that I implement the interface iEquality compare of employee. And I'll use Visual Studio to implement this interface for me. I just need to fill in the details. So there's two methods I need to implement. One is called equals. I get two employee objects. I have to figure out if they're the same or not, which really just means I need to compare the names of those employees. So let me return string.equals x.name and y.name. If those two strings are equal, then our employees are equal. I also need to implement getHashCode. The way I can do that is to return the hash code for the string that is the employee's name. That will make sure that two employees with the same name will generate the same hash code. And that will allow the hash set to identify duplicate employees. So given that little bit of code, what I need to do is take this employee compare, and when we create a new hash set, I can say, use this object to compare the incoming employee objects that you're going to receive. I'll do that on both hash sets. We'll make that prettier later. For right now, I just want to run the program and show you that that has achieved the goal. In the sales department, even though we tried to add two employees with the same name, Danny, the hash set only stored one of those. So the only two employees in sales are Joy and Danny. And of course, engineering is using a different hash set, so it's also allowed to have an employee named Danny. And this is great. This is an improvement. But now the business wants to see the departments in alphabetical order and also the employees in alphabetical order. So how will we do this? Well, you might remember there is a sorted set of employee. So now I'll say that departments are a sorted dictionary of string and sorted set of employee. And let me use sorted set down here. And what I'm hoping sorted set will do is order my employees correctly. However, sorted set's constructor is a little bit different. One of the versions doesn't want an iEquality compare of employee. It wants an iCompare of employee. The difference being that iEquality compare just checks to see if two objects are equal. And iCompare has to figure out if an object is less than another object or greater than another object, or if it is equal to an object. Because we not only have to prevent duplicates, we also have to keep things in the right order now. So now I need an iCompare of employee. And what I could do is continue using my employee compare. I'm just going to have it be an iEquality compare. Maybe I can use that somewhere else. But I also want it to be an iCompare of employee. And let me have Visual Studio implement that interface, bring this down to try to keep everything on the screen. And the method we have to implement now is the compare method. That's what an iCompare does. And again, what we want to do is compare employee objects by their name. So I'll delegate the work here to the string.compare method. Please compare x.name to y.name. And compare, if you didn't know, returns an integer. It's a convention that was established, I believe, by the C runtime libraries. At least that's the first place I saw it. When you do a comparison and return less than 0, that means the first object is less than the second object. If you return greater than 0, that means the first object is greater than the second object. And if you return exactly a 0, the two objects are equal. And that's exactly what string compare does given two strings. So now we have a class, employee compare, that is not generic, but it does implement two generic interfaces, I equality compare of employee and I compare of employee. So we know what types we're using. We pass along a type argument and essentially fill those interfaces in. And now we can use that employee compare with hash sets and with sorted sets. And hopefully when I run this program now, not only are the departments in alphabetical order, and not only are the employees not duplicated, but we're also automatically showing employees in alphabetical order. And that was all done just by implementing a few generic interfaces. But there's always something that bugs me about code like this. There's a lot of noise with the generic type parameters, with the compares. Let's look at cleaning that up.